All right, welcome back. And so right now we're actually going to simulate the layout that we've just created. As you remember, we simulated the schematic, but we also need to simulate the layout. As you know, this represents the physical, the way the circuit looks in physical silicon. So you'll be surprised that sometimes the simulation between the layout and the simulation uh, from the schematic are sometimes different. So let's get started. So if you go to Calibrate and you click Run PEX, what we first have to do is to export your entire layout out of Cadence into a couple of files, and we're going to eventually use another tool. So from here, just make sure, again, that you have the NCSU base kit tech file. Um, make sure that you're saving it in where where the project is being saved here in test and inverter. If you go to inputs, make sure that this says export from layout viewer. Go to netlist, make sure that this says Spice and this says export from schematic viewer. And everything else from here is set. If you go to outputs, make sure that this on netlist says Hpsice and that you use names from schematic. Nets, use all nets. From reports, make sure that this says PEX report is checked off. And on this last tab, just make sure that the start RV after PEX is selected. So we're going to hit run PEX and we're going to overwrite some files. Just click OK. And basically what Cadence is doing now is building your entire layout and just exporting it so we can use Hpsice. And what you should see then is all the different pins that we use in out and ground and VDD. And if all else is good, you should still see a smiley face right here. And cool. And that is actually all done. So we're gonna exit out of Cadence right now. We're gonna close everything. And we are now going to move. Oh, yep. Now we need to go into the folder where we've been saving everything. For me, it's here. This is, of course, the cell name INV. And as you can see, Cadence has created a couple different files from that last tool. And we really don't need to use all these files, but in order to simulate them, we're going to need to actually create another file. So if we just open up an editor, I'm just going to use gedit, and we're going to file save as, and make sure that you're saving it where all these other files are. So for me, I have it in test, which is the name of the library, if you remember, that we created, and INV is the name of the cell. So again, these are all the different files that Cadence has created. A lot of them you'll see is, PEX. And we're gonna save this. Let's call it INV underscore layout.sp. I'm gonna hit save. And I created a sample file earlier, and we're gonna just copy that from my desktop. So I'm going to bring it out here. And I'm going to explain a little bit about what this file really means. So we're going to be using a tool called Hpsice, and Hpsice is going to look into this file, and it's going to use this file to run the simulation for your layout. So this first line, so in order for this to really work, you have to make sure your first line is a space. I really don't know why. I just get errors when I don't have that. So just have that. So here it included just says, make sure you have that library that we've been working with all this time, the free PDK. And if you notice that this is actually the file that we used when we were simulating the schematic. Here we're gonna, Hpsice is gonna look for the definition of our inverter. And it's just saying include this file. And it's inv.pex.netlist, which is in this list of files that we have, which is right here actually. And if we're going to create a NAND or a NOR, you need to make sure you change this this INV to specifically NAND or NOR or whatever you've been looking for. In fact, you notice that with all of these, Cadence has created the prefix INV, to signify that this is the cell name. So when you create your other cell, just make sure you change that name. Afterwards, you're going to have this line. And so what this is saying is that Hpsice is going to create your circuit. It's going to call it X1. And as you create more circuits, it's going to call it X1, X2, X3, and so on and so forth. Now, it's important that you have this following piece correct. So let me show you where you would have to go. So if you go to this inv.pex.netlist file, if you look at this line that says .subcircuit, you have INV, which is the name of our cell. And these are the ports that we've been looking at, of course, in, out, and ground and VDD. You're going to want to copy these ports as they are in that order, and you're going to put it after that X1. So as you can see, we're going to have X1, and then from our list we have ground, VDD, in, out. So here we have X1, ground, VDD, in, out. And the last thing that goes on this line is the name of our cell, INV. And that's, it's kind of backwards here, but just know that, that's how Hpsice allows you to run it. Here, just another important thing before we move on. This trend line, this is going to be your transient analysis. If you remember when we were simulating the schematic, we're going to start at 0. We're going to move up until 1,000 picoseconds, and we're going to take a measurement every picosecond. And then finally, we just make sure we include this specific file. The important thing to note here is that you would want to change this to your net ID, and that you change this to whatever the name of your cell is. And obviously, if you're creating a NAND or a NOR, make sure that is changed into that. Cool. So we're going to save this, and we're going to close out, and let's go. I want to make sure I am in the correct directory where all these is. We're going to go into the terminal. I believe it's in test, INV. And yes, these files are here. And so in order to run Hpsice, you just type in Hpsice, and we're going to type in inv_layout.sp, which is the name of the file we just created. I'm going to put an arrow, and we're going to do inv layout test.out. So what this is saying is Hpsice is going to use our .sp file, and it's going to put all the outputs into this .output file. So we're going to hit enter, and if all goes well, you're going to see Hpsice concluded, and you're going to have a couple of more files in your directory. Now, in order to see the results, we're going to use another tool called CScope. And in order to see that, we're just going to type in scope. And this will come up. So we're going to go to File, Open, Plot Files, and we're gonna change this files type to all plot files, and you're gonna see inv layout.tr0. And we're gonna hit open, and you'll see that these are all kind of like the signals that come up in our simulation. We're going to hit on V in, which is the voltage in, and we're going to hit V out, and let's move these a little bit to the side, or maximizing this. So here you can see the input voltage and our output for our layout. And we can, if we click this and put it, drag it up here, we can see both of them at the same time. We can zoom in a little bit, and what you'll be able to see is that just like in our schematic, things are moving well here. For an input of 0, our output is high, and for an input of high, our input is low. I mean, our output is low. Sorry about that. And so you'll see that this worked fine because it's a very small circuit, but you'll see that with larger circuits, this simulation is going to look very different from, it could possibly be very different from the schematic and the schematic simulation. And you'll begin to see that everything depends really on your design, on your layout. If you made your transistor really big, if you made your rectangles too wide, you'll start to see some differences here. So this is the final thing that you want to get out, and you can play around with CScope a little bit more just to try to see the simulation. But this is what your product is going to look like. And so there you go. If you have any questions, feel free to leave it in the comment section. And and good luck, and thank you for watching.